Lithium deposit in extinct Nevada volcano could be largest in the world. A world-beating deposit of lithium along the Nevada-Oregon border could meet surging demand for this metal, according to a new analysis. An estimated 20 to 40 million tons of lithium metal lie within a volcanic crater formed around 16 million years ago. This is notably larger than the lithium deposits found beneath a Bolivian salt flat, previously considered the largest deposit in the world. If you believe their back-of-the-envelope estimation, this is a very significant deposit of lithium, says Anouk Borst, a geologist at KU Leuven University and the Royal Museum for Central Africa in Tervuren, Belgium. It could change the dynamics of lithium globally, in terms of price, security of supply and geopolitics. New in situ analysis reveals that an unusual claystone, composed of the mineral alite, contains 1.3% to 2.4% of lithium in the volcanic crater. This is almost double the lithium present in the main lithium-bearing clay mineral, magnesium smectite, which is more common than alite. To a geologist, the story of how these deposits were created is a fascinating tale. The McDermott caldera formed 16.4 million years ago when some 1,000 cubic kilometers of red-hot magma exploded outwards. The caldera was filled with erupted products of an alkaline magma rich in sodium and potassium, as well as lithium, chlorine, and boron. This quickly cooled to form a finely crystalline glassy volcanic rock, ignimbrite, which weathered to produce lithium-rich particles. A lake subsequently formed in the crater, persisting for hundreds of thousands of years with weathered volcanic and surrounding materials forming a sediment rich in clay at its bottom. The new analysis suggested that after the lake emptied, another bout of volcanism exposed the sediments to a hot, alkaline brine, rich in lithium and potassium. Previous research assumed that the alite was everywhere at depth in the caldera, says Benson, who is a geologist at Lithium Americas Corporation, LAC, and was formed when high temperatures and pressures turned smectite to alite. Benson's team proposed that a layer of alite about 40 meters thick was formed in the lake sediments by this hot brine. The fluid moved upwards along fractures formed as volcanic activity restarted, transforming smectite into alite in the southern part of the crater known today as Thacker Pass. The result was a claystone rich in lithium. The material could be best described as looking a bit like brown potter's clay, said Christopher Henry, emeritus professor of geology at the University of Nevada in Reno. It is extremely uninteresting except that it has so much lithium in it. There's been a lot of searching for additional deposits, Henry added. The United States currently has just one small lithium-producing brine operation in Nevada. Benson says his company expects to begin mining in 2026. It will remove clay with water and then separate out the small lithium-bearing grains from larger minerals by centrifuging. The clay will then be leached in vats of sulfuric acid to extract lithium. If they can extract the lithium in a very low energy-intensive way, or in a process that does not consume much acid, then this can be economically very significant, says Borst. The US would have its own supply of lithium and industries would be less scared about supply shortages.